Hi, welcome to this Corbettmaths video. In this video, we're going to look at the video solutions to the practice questions on enlargements. If you need any extra help on enlargements, if you go to Corbettmaths and watch video numbers 104, 105, 106 and 107, they're very useful video tutorials there on enlargements. Alternatively, you could scan this QR code. But in this video, we're going to focus on the video solutions to the practice questions on enlargements, so let's get started. Okay, question number one. Question number one, we've got this grid and we've got this shape, and part A says to name the shape drawn on the grid. So let's name the shape drawn on the grid. So let's count the number of sides. So we've got 1, 2, 3, 4, 5, 6, 7, 8 sides. And a polygon with 8 straight sides is called an octagon. So that's an octagon. Okay, and then part B. Part B says on the grid, enlarge the shape using scale factor 2. So we want to enlarge this octagon by scale factor 2. So that means we want to make all the sides twice as long. So the base here, instead of being 1 square across, it's going to be 2 squares across. So let's draw this. So let's get a ruler and pencil. So I've got a ruler here and a pencil. And I'm going to draw a base which is 2 squares across. So I'm going to do that base of 2 squares across like so. Then we've got a diagonal, and that diagonal goes from one corner to another corner, but we're going to double that. So instead of being one diagonal, we're going to have 2 diagonals. So it's going to go 1, 2, like so. And likewise on the other side, we've got another diagonal. So we're going to double the length of that. So that'll be 2 diagonals, like so. Then we've got the 2 sides. They did have a length of 1. We're going to double that. So they've now got a length of 2, like so. So they're going to go up and up. Then we've got the 2 diagonals going in. So again, instead of being 1 diagonal, they're going to be 2. So we're going to go 1, 2. And likewise here, we're going to have 1, 2. And then finally, we've got the top of the octagon, and it was 1 square across. Now it's going to be 2 squares across. So it's going to be like that. And that's it. So we've enlarged that octagon by scale factor 2. And that's our answer. And let's just check, do we need to do anything else? No, that's it. So we've enlarged the shape using scale factor 2. And that's it. Okay, let's look at our next question. Okay, so question number 2, so we've got this grid and we've got this little cross on the grid. And the question says, on the grid, enlarge the shape using scale factor 3. So that means all the sides are going to become 3 times larger. So instead of the base being 1 square across, it's going to be 3 squares across. Instead of going up 1 square, we're going to go up 3 squares and so on. So let's draw that. So we're going to get a ruler and pencil, and we're going to go 3 squares across, like so. Then, instead of going 1 square, we're going to go 3 squares up, like so, and like so. Then our side here and here, instead of being 1 across, we're going to go 3 across. So it's going to go to there and to there. Then instead of going 1 up and 1 up, we're going to go 3 up and 3 up. And now we've got this side, and they're 1 square across, so we're going to go 3 squares across, like so and like so. And you can see the shapes forming. And then instead of 1 up and 1 up, we're going to go 3 up and 3 up, and then hopefully we'll go 3 across to join them. So let's see. So if we go 3 up and 3 up, we then just go 3 across to join them, like so. And that's it. So we've enlarged that cross by scale factor 3, and that's it. Okay, let's look at our next question, question number 3. So question number 3, we've got this triangle here, and this triangle is a scalene triangle. It's a scalene triangle because all 3 sides have got different lengths and the angles are all different sizes. And the question says, on the grid, draw an enlargement of shape A, or triangle A, using scale factor 2. So we need to double the length of all of the sides. So let's start off with the base. The base was 1, 2, 3, 4 across. So we're going to double that, so ours would be 8 across. So I'm just going to go up here and I'm going to do 8 across. So 1, 2, 3, 4, 5, 6, 7, 8. And let's just check that. 1, 2, 3, 4, 5, 6, 7, 8. So that's 8 across. Fantastic. So that's the base of the shape, like so, the base of that triangle. Okay, now we need to figure out where the top of the triangle will be. Now there's a few different ways we can do that. One way we can do it is, I'm going to look at this line here. This line here, it's 1 across and it's 1, 2 up. So instead of, because it's scale factor 2, so for this line, instead of going 1 across and 2 up, we're going to double it. So we're going to, instead of going 1 across and 2 up, we're going to go 2 across and 4 up. So let's go to this point here, and we're going to go 2 across and 4 up. So 2 across, 1, 2, and 4 up. 1, 2, 3, 4. So that's there. So that's where the top of the triangle will be. So what we done there was we looked at this side and it was 1 across and 2 up. So we doubled it to be 2 across and 4 up. Likewise, we could have looked at this line on the other side, this line here. And this line is 1, 2, 3 across and 1, 2 up. So that's 3 across and 2 up. If we double that, it'd be 6 across and 4 up. So 6 across, 1, 2, 3, 4, 5, 6, and 4 up. 1, 2, 3, 4. So that's it. That's the top of the shape. And that's it. So now we just need to join them up. So we'll just get a ruler and pencil and we'll join up to the top of the triangle and then down the other side there, like so. And that's it. We've enlarged that triangle by scale factor 2 on the grid. And that's it. Okay, let's look at our next question. Okay, so let's have a look at our next question, question number 4. So question number 4 says two rectangles, A and B, are drawn on a centimetre grid. So we've got two rectangles here, A and B. And if we go down to our question, part A says work out the area of rectangle A. Now if we go up, it says a centimetre grid. That means this is a centimetre square grid. So it means that each one of the squares measures 1 centimetre by 1 centimetre. So 1 centimetre by 1 centimetre. And that means the area, if we do 1 times 1, that's 1 centimetre squared. So that means that each square has got an area of 1 centimetre squared. So here we want to find the area of rectangle A. So we just need to count the number of squares. So that'd be how many centimetres squared it is. So it's 1, 2, 3, 4, 5, 6, 7, 8. So the area of rectangle A is 8 centimetres squared. So that's 8 centimetres squared. Okay, and then we're told rectangle B is an enlargement of rectangle A. So as you can see here, rectangle B, let's just see, it says it's an enlargement of rectangle A. So here the height of A is 1, 2, and the height of B is 1, 2, 3, 4. So the height is doubled. Let's look at the length. So the length of A is 1, 2, 3, 4. If you double that, you get 1, 2, 3, 4, 5, 6, 7, 8. So yeah, so rectangle B is an enlargement of rectangle A. The sides have been doubled. So instead of it being 2 and 4, it's 4 and 8. And then the question says, what is the scale factor of enlargement? So the scale factor of enlargement is how many times larger the sides are. So here this was 4 centimetres and that's 8 centimetres. So that's 2 times larger. So we times by 2, so that means it's 2 times larger. And likewise with the height of this one is 2 centimetres and the height of this one is 4 centimetres. And again, that's 2 times larger, so multiply by 2. So the scale factor of enlargement is 2 because we've doubled the length of the sides. So the scale factor of enlargement is 2. Okay, let's look at our next question, question number 5. So question number 5 says the diagram shows a triangle and the dotted line is a side of an enlargement of the triangle. So let's have a look and see what we've got here. So we've got this triangle, A, and then we've got this dotted line. And this is a side of the enlargement of this triangle. And part A says what's the scale factor of enlargement? So what's the scale factor of enlargement? So let's look at the base of A. So the base of A is, and is it a centimetre square grid? So let's look at the base of A, and the base of A is 1, 2, 3 across, and the length of this line is 1, 2, 3, 4, 5, 6, 7, 8, 9, so that's 9 across. So that's 3 times larger. So because the base of this triangle is 3 times larger than the base of this triangle, the scale factor of enlargement is 3 because it's 3 times larger, so times by 3. And then part B asks us to complete the enlarged triangle, so we need to complete the enlarged triangle. So that means that this triangle is going to become 3 times larger than this one. So we need to figure out where the top of the triangle will be. So if we have a look at this one, to get to the top of the triangle, if we start here, we go 1 across and 1, 2 up. So we go 1 across and 2 up. Now the scale factor of enlargement is 3. So instead of going 1 across and 2 up, we're going to times that by 3. So we're going to go 3 across and 6 up. So let's start it with this corner, and we're going to go 3 across and 6 up. So 3 across, 1, 2, 3, and 6 up. 1, 2, 3, 4, 5, 6. That's there. So the top of this triangle will be here. Another way we could do is we could look at this corner and say to get to the top of the triangle from this corner, we go 2 across and 2 up. So we times that by 3, we'll go 6 across and 6 up. So 6 across, 1, 2, 3, 4, 5, 6, and 6 up. 1, 2, 3, 4, 5, 6, and that's it. Or actually in this one, this side here, we've got it's going through the diagonals. So it goes through 1, 2 diagonals. So we can multiply that by 3. So it'll be 6 diagonals. So it'll be 1, 2, 3, 4, 5, 6. That's there. So that's the top of the triangle. So we've been asked to complete the triangle. So let's get our ruler. So let's get our ruler and pencil and join up the top of the triangle, and like so. And that's it. We've enlarged triangle A by scale factor 3. And did the question ask us to do anything else? No, that's it. We just needed to complete the enlarged triangle. So that's what it would look like. Okay, so let's have a look at our next question, question number 6. So question number 6 says, shown below is an L shape that has an area of 9 centimetres squared. So let's have a look at this L shape. So here we've got this L shape, it's a backwards L, I suppose, and its area is 9 centimetres squared. Let's just check. 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah, so that's 9 centimetres squared. So that means that each little square has got an area of 1 centimetre squared. And the question says, work out the area of an L shape after an enlargement of scale factor 2. So we need to enlarge this by scale factor 2. And don't just double the area. Some students will think, well, if the area of this one is equal to 9 centimetres squared, that we would double it and that would be 18 centimetres squared. But that's not the case for the area. It would work for the length of the sides. If you enlarge by scale factor 2, the length of the sides double, but the area actually more than doubles. And we'll have a look at that in a second. So what we're going to do is we're going to enlarge this shape A by scale factor 2. So let's enlarge it by scale factor 2. So in terms of the base of this L shape, it's 1, 2, 3 across. Now we want to enlarge by scale factor 2, so if we double 3 across, that'll be 6 across. So let's do 6 across. 1, 2, 3, 4, 5, 6. That's 6 across, like so. Now the height of A is 1, 2, 3, 4. So we're going to double that. That's going to be 8 up. So the height of our new shape is going to be 8 up. So 1, 2, 3, 4, 5, 6, 7, 8. That's there. Next, the top of the shape. The top of the shape was 2 across. So we're going to double that. So it's going to be 4 across. So that's going to be there. It did go 3 down. So we're going to double that. That's going to be 6 down. So 1, 2, 3, 4, 5, 6, like so. Then it was 1 across, so we're going to double that. That's going to be 2 across. And finally, it was 1 down. It's now going to be, if we double that, 2 down. And that's it. So we've enlarged A by scale factor 2. And that's our enlargement. And the question asks us to work out the area of the L shape after enlargement of scale factor 2. So if this has been enlarged by scale factor 2, and we have enlarged it by scale factor 2, we now just need to work out its area. So let's work out its area. And I'm actually just going to count the number of squares because we counted the number of squares here. That's 9 centimeters squared. So let's count the area of this one. So it's going to be 1, 2, 3, 4, 5, 6, 7, 8, and I'll just do the rest now. And that's it. So the area of this shape is 36 centimeters squared. And that's it. So the area of this one was 9 centimeters squared, and the area of this one is 36 centimeters squared. And the question is asked us to work out the area of that shape. So it's going to be 36 centimeters squared. And that's it. So as you notice here, the area of this one wasn't just 2 times larger because it's not 18 centimeters squared. It's 36 centimeters squared. It's actually 4 times larger. And that's it. Okay, let's look at our next question. Okay, so let's have a look at our next question, question number 7. So question number 7, we've got this grid and we've got this point P here, and point P is the center of enlargement, and we've got this shape here, A. We've been asked to enlarge shape A by scale factor 4 using P as the center of enlargement. So what we're going to do is we're going to enlarge this shape A by scale factor 4. So that means that all the sides are going to become 4 times larger, but it's also going to become 4 times further away from this point P. So let's do each point of this shape, okay? So let's start off with this point here. To get to this point, we would go 1 across, or 1 square to the right. But because we're enlarging by scale factor 4, instead of going 1 to the right, we're going to go 4 to the right. So we're going to go back to this P and we're going to go 4 to the right. So 1, 2, 3, 4 would be there. Okay, now the bottom right hand corner. To get to the bottom right hand corner from P, we would go 1, 2, 3 to the right. So we're going to times that by 4 because the scale factor of enlargement is 4. So instead of going 3 to the right, we're going to go 12 to the right. So let's go back to P and go 12 to the right. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So that's there. So we've now got the base of A. We could at this point actually draw an edge, just knowing that each of the sides are going to become 4 times larger. But I tend to do lots of the points actually. So let's carry on and let's do this point here. So this point here, to get to this point, we would go 1 to the right and 1, 2 up. So instead of going 1 to the right and 2 up, we're going to times that by 4. So that'll be 4 to the right and 8 up. So 4 to the right would be 1, 2, 3, 4. And then 8 up would be 1, 2, 3, 4, 5, 6, 7, 8. So that would be there. So that's then that point would move to there. So to get to this point, we would go 2 to the right and 2 up. So we're going to times that by 4 because the scale factor of enlargement is 4. So that would be 8 to the right and 8 up. So 8 to the right, 1, 2, 3, 4, 5, 6, 7, 8. And 8 up, 1, 2, 3, 4, 5, 6, 7, 8. So that point would move to there. And as you can see now, we've got 4 of the points of this enlarged shape A. We can actually draw this at this point because we know we would then go down 1 square. So we would go down 4 squares because it's 4 times larger. We would then go to the right 1. So we because it's 4 times larger, we would go 4 to the right and then 4 down. But let's just do a few more points just to see. So this point here, it's 1, 2 to the right and 1 up. We're going to multiply that by 4, so that'll be 8 to the right and 4 up. So 8 to the right, 1, 2, 3, 4, 5, 6, 7, 8, and 4 up, 1, 2, 3, 4. That would move to there. And finally, this point here. This point is 3 to the right and 1 up. So we're going to times that by 4, so that'll be 12 to the right and 4 up. So 12 to the right, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and 4 up, 1, 2, 3, 4. So it'll move to there. And as you can see now, we've got all the points of this enlargement. So let's join them up. And that's it. So we've enlarged shape A by scale factor 4 using P as the center of enlargement. So all the sides are 4 times larger, and you can check that. But also this shape is 4 times further away than shape A from the point P. And then the question, do we need to label it? No, that's it. We've enlarged it by scale factor 4 using P as the center of enlargement. Okay, let's look at our next question. Okay, so let's have a look at our next question, question number 8. So question number 8, we've got this set of axes, our x-axis and y-axis, and we've got this rectangle labelled A. And then we're told to enlarge A by scale factor 3 with centre 0, 0. So we've got the centre of enlargement, it's the origin 0, 0. So I'm just going to put a little crosshair at the origin of the point 0, 0. And that's going to be our centre of enlargement. So we need to enlarge rectangle A by scale factor 3 using this point as the centre of enlargement. And that means that this rectangle A is going to become 3 times larger and also 3 times further away from this point here. So let's do that. So let's go up to our shape, and what we're going to do is we're going to make each of the points become 3 times further away from this point. So this point here, the bottom left hand corner of A, we would go 1 to the right and 2 up. Because the scale factor of enlargement is 3, what we're going to do is we're going to times those distances by 3. So instead of going 1 to the right and 2 up, we're going to times that by 3. So we're going to go 3 to the right and 6 up. So 1, 2, 3, 4, 5, 6. That's going to be there. Okay, now this point here, this point is 3 to the right and 2 up. So we're going to times that by 3, so it's going to be 9 to the right and 6 up. So 9 to the right, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 6 up, 1, 2, 3, 4, 5, 6. That's going to be there. Okay, now the top left hand corner, it was 1 to the right and 1, 2, 3 up. So instead of going 1 to the right and 3 up, we're going to go 3 to the right and 9 up. So 3 to the right, 1, 2, 3, and 9 up, 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's going to be there. Now at this point, you could probably just draw the rectangle and know that the last point is going to be here. But let's do it anyway. Let's check it. So this point is 3 to the right and 3 up. We're going to enlarge it by a scale factor of 3. So it's going to be 9 to the right and 9 up. So 9 to the right, 1, 2, 3, 4, 5, 6, 7, 8, 9. And 9 up, 1, 2, 3, 4, 5, 6, 7, 8, 9. And that's it. And now we just need to get a ruler and pencil and join up those points. And that's it. We've joined up all those points. And let's just check, do we need to label it or anything? No, that's it. So we've enlarged rectangle A by scale factor 3 using the origin of the point 0, 0 is the center of enlargement. And that's it. So that's question number 8 completed. Okay, now question number 9. So question number 9, we've got another set of axes and we've got a right angle triangle there. We've been asked to enlarge the triangle by scale factor 2 using the center of enlargement 0, 0, so the origin again. Now it's not always the origin, and we'll look at some questions in a moment where we've got other center of enlargements. So here the center of enlargement is the origin, so I like to put a little cross there to say that's the center of enlargement. And we're going to make this triangle, this right angle triangle, 2 times larger but also twice as far away from the center of enlargement. So let's do that. So let's start off with this point. So this point was 1 to the left and 2 up. So instead of going 1 to the left and 2 up, we're going to double it, and we're going to go 2 to the left and 4 up. So 2 to the left, 1, 2, and 4 up. 1, 2, 3, 4. So it's going to move to there. Okay, this point here was 1 to the left and 1 down. So we're going to double that. So it's going to be 2 to the left and 2 down. So 2 to the left, 1, 2, and 2 down. 1, 2 will be there. And this point was 1, 2, 3 to the left and 1, 2 up. So instead of going 3 to the left and 2 up, we're going to double that. So it's going to be 6 to the left and 4 up. So 6 to the left, 1, 2, 3, 4, 5, 6, and 4 up, 1, 2, 3, 4. So that's going to be there. So we've made all the points of this triangle twice as far away from the center of enlargement. Now if we just join them up, that's going to be our enlargement. So let's get our ruler and pencil and let's join up these points. And that's it. And do we need to label it? No, that's it. So we've enlarged this triangle by scale factor 2 using the origin of the point 0, 0 as the center of enlargement. Okay, let's look at our next question. So question number 10, we've got our x-axis and y-axis here, and we've got trapezium C and trapezium D. And the question says, describe fully the transformation that maps trapezium C onto trapezium D. So we need to describe the transformation that takes trapezium C onto trapezium D. Now, first of all, you can see it's been an enlargement. In terms of our transformations, we've got a few choices. We've got a translation, that's where it's been slid. We've got a reflection, where it's been reflected. A rotation, where it's been spun or rotated. And finally, an enlargement. And because the sizes of the shapes have changed, this is an enlargement. Now, if we have a look at this, the base of C is 1, 2 across, and the height of it is 1, 2, 3 up. And if we have a look at D, the base of D is 4 across, and the height of D is 1, 2, 3, 4, 5, 6 up. So if we have a look at this, the lengths of the sides have been doubled. So here this had a length of 2 and this is a length of 4. This had a height of 3 and it's now got a height of 6. So the lengths of the sides have been doubled. So that means the scale factor of enlargement is 2. So let's write this down. So far it has been enlarged. So to map C onto D, it's an enlargement by scale factor 2. Because the sides have been doubled. But we also need to describe, because this is described fully, we need to say where the center of enlargement is. So if we go up here, let's find the center of enlargement. Now, if we have trapezium C and it's been enlarged, and its enlargement is trapezium D, the center of enlargement is going to be over here somewhere. And what we're going to do is we're going to get a ruler and pencil, and we're going to start off with this point here, and we're going to join a line that goes through the corresponding point of C and carry on, like so. So if we draw that line, it would look something like that. And it would look something like that. Now what we're going to do is we're going to choose 2 of our corresponding points. So I'm going to choose the bottom right hand corner and the bottom right hand corner. So I'm going to start off with this point here, and I'm going to draw a line that goes through from that point through the other point like so and carries on like so. Now if we have a look here, we can see that those two lines, they cross at the same point here. So this point here will be the center of enlargement. So the center of enlargement is the point 0, 0. So that means that this point here will be the center of enlargement, the point 0, 0. And we can just check that. Let's choose another pair of corresponding points. I'm going to choose the bottom left-hand corner and the bottom left-hand corner. If you start off with the enlargement and you go through the original shape here, the object, and you draw a line going straight through them, you'll see it also goes through the point 0, 0. And that'll work for all the points, because remember that they're all becoming twice as far away from the center of enlargement. So if you were to draw lines through them, they'll all meet at the center of enlargement. So we need to write down the center of enlargement is the point 0, 0. So that means it's enlargement by scale factor 2 with center of enlargement, 0, 0. And that's it. Okay, let's look at our next question. Okay, so let's have a look at our next question, question number 11. So question number 11, we've got this grid, our x-axis and y-axis, and we've got this triangle, ABC, and we've got this point here, P. And if we look at the question, it says enlarge triangle, ABC, by scale factor 2 using P as the center of enlargement. So we want to enlarge this triangle by scale factor 2, and P is the center of enlargement. So it's not the origin this time, it's this point P, which is the point 5, 4. So what we want to do is we want to make this triangle twice as large, because the scale factor of enlargement is 2, but it's also going to come twice as far away from this point P, the center of enlargement. So let's start off with A. So to get from P to A, we would go 1, 2, 3, 4 across and 1 down. Now we're going to double that because the scale factor of enlargement is 2. So instead of going 4 to the left and 1 down, we're going to go 8 to the left and 1 down. So let's go 8 to the left. 1, 2, 3, 4, 5, 6, 7, 8. And instead of going 1 down, we're going to go 2 down. So 1, 2. So it's going to be there. And actually I'm going to label it. And that was the point A. And I'm just going to label this. So this would be A dash. So whenever we complete our transformation here, our enlargement, if this was the object A, B, C, in terms of our image, we're going to label it A dash, B dash and C dash. Now the question actually didn't say we had to label it, but I'm just doing it in case you see that notation. Okay, now in terms of B, so to get from P to B, we would go 2 to the left and 1 down. Because of scale factor 2, we're going to go 4 to the left and 2 down. So 4 to the left, 1, 2, 3, 4, and 2 down, 1, 2. So that's going to be there. So if this was the point B, this would be the point B dash. Okay, and then C. C, to get from P to C, we would go 1, 2, 3 to the left and 1, 2, 3 down. So we're going to enlarge that by scale factor 2. So we're going to double it. So instead of going 3 to the left and 3 down, we're going to go 6 to the left and 6 down. So 6 to the left, 1, 2, 3, 4, 5, 6, and 6 down. 1, 2, 3, 4, 5, 6. That's going to be there. And that'll be the point C dash. So we've made all these points twice as far away from point P, the center of enlargement. Now we just need to join them up. So let's get a ruler and pencil and let's join them up. And that's it. So we've enlarged triangle ABC by scale factor 2, and we've got A dash, B dash, C dash, and that's it. And that's it. Did the question say we had to label it? No, that's it. So we've enlarged it by scale factor 2 using P as the center of enlargement. And that's it. Okay, let's look at our next question. Okay, so question number 12. Question number 12, we've got this rectangle on a coordinate grid, and we've been asked to enlarge this rectangle by scale factor 2 using the center of enlargement -1, 0. So I'm going to plot this point -1, 0. So -1, 0 would be here. So that's the center of enlargement. So that means because the scale factor is 2, we're going to make all the points become twice as far away from this center of enlargement here. So let's do that. Okay, so to get to this point from the center of enlargement, we would go 1 to the left and 2 up. So instead of going 1 to the left and 2 up, we're going to double it, and we're going to go 2 to the left and 4 up. So 2 to the left, 1, 2, and 4 up. 1, 2, 3, 4. So that would be there. Okay, so now let's have a look at this point. So to get to this point from the center of enlargement, we would go 1, 2, 3 to the right and 1, 2 up. So instead of going 3 to the right and 2 up, we're going to double that because the scale factor of enlargement is 2. So we're going to go 6 to the right and 4 up. So 6 to the right. So we'll go back to the center of enlargement and go 6 to the right. 1, 2, 3, 4, 5, 6. That's here. And then we're going to go 4 up. 1, 2, 3, 4. So it's going to be there. Okay, so we've done that point and that point. Now we've got these 2 points down here. So this point here, to get to this point here, we would go 1 to the left and 1 down. So we're going to double that. So instead of going 1 to the left and 1 down, we're going to go 2 to the left and 2 down. So 2 to the left, 1, 2, and 2 down, 1, 2. So it's going to move to there. And then finally this point here, to get to this point here from the center of enlargement, we would go 1, 2, 3 to the right and 1 down. So instead of going 3 to the right and 1 down, we're going to go 6 to the right and 2 down. So 6 to the right, 1, 2, 3, 4, 5, 6, and 2 down, 1, 2. So it's there. So we've got our 4 points. Now we just need to get a ruler and pencil and join them up. And that's it. So we've enlarged this rectangle by scale factor 2 using the point -1, 0 as the center of enlargement. And that's it. Okay, let's have a look at our next question, question number 13. Okay, question number 13. So we've got this grid with our x-axis and y-axis, and we've got this trapezium here. And the question says, enlarge the trapezium by scale factor 3 using center 6, 0. So we want to enlarge this trapezium by scale factor 3 using the center 6, 0. So the center 6, 0 will be here, 6, 0. I'm just going to plot that point. And we want to enlarge this by scale factor 3. So it means that all the points are going to become 3 times as far away from this center of enlargement here, 6, 0. So let's start off with this point here, so this bottom left-hand corner. So to get to this bottom left-hand corner, we would go from the center of enlargement, 1, 2 to the left, and 1 up. Now the scale factor of enlargement is 3, so instead of going 2 to the left and 1 up, we're going to times that by 3, so that'll be 6 to the left and 3 up. So 6 to the left, 1, 2, 3, 4, 5, 6, and 3 up, 1, 2, 3, so that'll be there. Okay, now, so that's that point done. Okay, now let's do this point here. So to get to this point from the center of enlargement, we would go 1 to the left and 2 up. So we're going to times that by 3. So instead of going 1 to the left and 2 up, we're going to times that by 3. So that'd be 3 to the left and 6 up. So 3 to the left, 1, 2, 3, and 6 up. 1, 2, 3, 4, 5, 6. That's going to be there. Okay, now this point here. So this point here, to get to this point here, we would go 1, 2 up. So we're going to times that by 3. So instead of going 2 up, we're going to go 6 up. So we go 1, we'll go back to center of enlargement, we'll go 1, 2, 3, 4, 5, 6. That's going to be there. And finally, the bottom right-hand corner, it was 1 up from the center of enlargement. So we're going to times that by 3, so it's going to be 3 up. So 1, 2, 3, so it's going to be there. So we've now got our 4 points. We now just need to join them up. So we get our ruler and pencil, and we're just going to join them up. So there to there, there to there, there to there, and from there to there. And that's it. We've enlarged the trapezium by scale factor 3 using the center 6, 0. And let's just check that. The base of the original trapezium was 2, and this is 1, 2, 3, 4, 5, 6. And the height of this one was 1, the height of this one's 3, and so on. So that's it. We've enlarged this trapezium by scale factor 3 using center 6, 0. Okay, let's look at our next question, question number 14. So question number 14 says that rectangle A is an enlargement of rectangle D, and they're on a centimetre grid. So this is a centimetre grid, so that's 1 centimetre by 1 centimetre, and its area would be 1 centimetre squared. So we've got E is an enlargement of D, and then if we scroll down, part A says what is the scale factor of enlargement? So let's look at the length and the width of each of the rectangles. So in terms of D, its length would be 1, 2, 3 centimetres, because remember it's a centimetre grid, so that's 3 centimetres. And in terms of E, the length of it is 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's 9 centimetres. And then in terms of the width of D, the width of D is 1.5 centimetres, 1.5 centimetres. And in terms of E, it's 1, 2, 3, 4.5, so 4.5 centimetres. So in terms of the scale factor of enlargement, to get from 3 to 9, we'd multiply by 3. And likewise, to get from 1.5 to 4.5, again, we'd multiply by 3. So the scale factor of enlargement is 3. And then we're told that rectangle E, so rectangle E, this rectangle up here, which is 9 centimetres by 4.5 centimetres, I'm just going to write that down, that it's 9 centimetres by 4.5 centimetres. That rectangle E is enlarged by scale factor 20 to give us rectangle F. And the question then says, write down the length and the width of rectangle F. Now we know that whenever we enlarge something by scale factor 20, that the sides become 20 times bigger. So we just need to multiply the length of rectangle E by 20 to get the length of rectangle F, because it's going to be 20 times bigger. And likewise, we need to multiply the width of rectangle E, the 4.5 centimetres by 20, and then that'll give us the width of rectangle F. So we're going to do 9. So we're going to do 9 multiplied by 20, and 9 times 2 is 18, so 9 times 20 is 180, so that's 180 centimetres. And then we need to do 4.5 times 20, so 4.5 multiplied by 20. Now, there's a few different ways we could approach this. One way is to do 4.5 times 2, which is 9, so 4.5 times 20 would be 90. Or another way to do it is to recognise that 4.5 is half of 9, so that means that we just half the 180, and that would be 90. So it's going to be 90 centimetres wide. So that's the width of it, 90 centimetres. And that's it. So the length of rectangle F is 180 centimetres, and the width of rectangle F is 20 centimetres, just multiplying the length and the width of rectangle E by 20. And that's it. Okay, let's have a look at our next question, question number 15. So question number 15, we've got this right angle triangle A on the grid. We've been asked to enlarge this triangle by scale factor 2 using centre of enlargement 5, negative 5. So let's plot where 5, negative 5 would be. So let's just get our pencil and then put a little cross at 5 minus 5. So 5 minus 5 will be there. So that's the centre of enlargement, and we need to enlarge this triangle by scale factor 2. So that means that the sides are going to become 2 times bigger, but it's also going to be twice as far away from the centre of enlargement. So let's find out where it'll be. So if we start off with the bottom bottom point here. To get from the center of enlargement to this point, we would go 1, 2, 3, 4 to the left and 1 up. So we're going to double that. So it'll be 8 to the left and 2 up. So 8 to the left, 1, 2, 3, 4, 5, 6, 7, 8, and then 2 up, 1, 2. So that would be there. Okay, the top point here, that would be to get to that point from the center of enlargement, you go 1, 2 left and 1, 2, 3 up. So 2 left and 3 up. So we're going to multiply that by 2, so that'll be 4 left and 6 up. So 4 left, 1, 2, 3, 4, and 6 up. 1, 2, 3, 4, 5, 6 would be there. And then finally this point here, to get to this point here from the center of enlargement, we would go 1, 2, 3, 4 left and 1, 2, 3 up. So it's 4 left and 3 up. So we're going to double that. So it's going to be 8 left and 6 up. So 8 left, 1, 2, 3, 4, 5, 6, 7, 8, and 6 up. 1, 2, 3, 4, 5, 6 would be there. So we've now got the 3 points, so now we just need to join them up. And that's it. And then the question said we didn't need to label or anything, so that's it. We've enlarged this triangle A by scale factor 2 using this 0.5, -5 as a center of enlargement. And then that's our answer. And that's it. Okay, let's look at our next question. Okay, so question number 16, we've got the trapezium A and trapezium B, and the question says, describe fully the single transformation that maps shape A onto shape B. So what transformation takes shape A onto shape B? So it's not going to be a translation or a reflection or a rotation, it's definitely an enlargement because trapezium B is bigger than trapezium A. So we just need to find the scale factor of enlargement, say it is an enlargement, and also find where the center of enlargement would be. So let's start off by writing this down so far. So we've just started by writing an enlargement because we know it's an enlargement by scale factor, and now we just need to find what the scale factor would be. So in terms of trapezium A, we would go 2 across, 1, 2. And in terms of trapezium B, it's 1, 2, 3, 4 across. It's twice as large. And then in terms of the height of trapezium A, this length here, it's 1, 2, 3. And then the height of trapezium B would be 1, 2, 3, 4, 5, 6 is double it. So the scale factor of enlargement is 2. By scale factor 2 with center of enlargement. And now we just need to say where the center of enlargement would be. So here we've got trapezium A and trapezium B. Well, A has been enlarged and it's given us trapezium B. So the center of enlargement is going to be over here somewhere. So let's get our ruler and our pencil. And what we're going to do is we're going to draw lines through the corresponding points. So I'm going to start off with this top right point here and this top right point here. So I'm going to draw a line through those points and then carry it on. So it looks something like that. Then I'm going to do this bottom point here and this bottom point here. So again, I'll get my ruler and pencil and I'll put it there and I'll draw a line through those two corresponding points. You can see here they've crossed at the same point there, the point 7, 6. Let's try another one and just make sure it's to the top left and the top left. And if we draw that line again through the point 7, 6. And also just for completeness, let's do the bottom right point and the bottom right point. And again, they pass through the point 7, 6. So that means the center of enlargement is this point here, the point 7, 6. So let's write that down. That there has been enlarged by scale factor 2 with center of enlargement 7, 6. And that's it. Okay, let's have a look at our next question. So question number 17. So question number 17, again, we've got trapezium A and trapezium B. And the question says, describe fully the single transformation that maps A onto B. So we've got trapezium A and we've got trapezium B, and you can see it's not a translation or reflection or rotation, it's definitely an enlargement that takes A onto B. And we want to describe fully the single transformations. Let's explain this. So it's an enlargement by scale factor, and let's find the scale factor of enlargement. So how many times bigger is trapezium B than trapezium A? So in terms of the base of trapezium A, it's 1 across, and in terms of the base of trapezium B, it's 1, 2, 3 across. So I think at this point the scale factor of enlargement is going to be 3. Now let's just double check that. The height of trapezium A, so this 2 up here, this left hand side, and then if you times that by 3, that should be 6 up. So let's just check 1, 2, 3, 4, 5, 6. So yeah, the scale factor of enlargement is 3. By scale factor 3 with center of enlargement, and now we just need to find where the center of enlargement would be. Now if we've enlarged trapezium A and it's gone over here somewhere, the center of enlargement is going to be down in this direction here somewhere. So what I'm going to do is I'm going to start off with this point and I'm going to draw a line through the same point in trapezium A and then carry on like so. Then we'll do the top left hand point here and we'll go through the top left hand point of A and it's going to look something like this. And then in terms of this bottom left one and this bottom left one, it would look something like that. And as you can see, these lines are all crossing over at this point here, the point 4, -5. So it's going to be the center of enlargement, 4, -5, 4, -5. So that's the center of enlargement. So the single transformation, the map shape A onto shape B, would be an enlargement by scale factor of 3 with center of enlargement 4, -5. And that's it. Okay, let's look at our next question. Okay, so question number 18. So question number 18, we've got this right angle triangle, ABC. And the question says that triangle ABC is drawn on the grid, and we've been asked to enlarge this triangle ABC using a scale factor of 1/2 with center 0, 0. So we're using a scale factor of 1/2. So this time, in terms of the lengths of the sides, they're actually going to become half the size. Because if the scale factor was 2, all the sides would double. You'd multiply them all by 2. If the scale factor is 1/2, they're going to be half the size. So, and the center of enlargement is 0, 0. So I'm just going to put a cross there on the center of enlargement. So all of these points in this triangle, ABC, they're going to become half as far away from the center of enlargement here. So in terms of A, to get to A from the center of enlargement, we would go 1, 2 to the right, and 1, 2, 3, 4, 5, 6 up. So instead of going 2 to the right and 6 up, we're going to half that. So it's going to be 1 to the right and 3 up. So 1 to the right and then 3 up. 1, 2, 3 would be there. So that's where A would move to. It's got to be A dash. In terms of B, well, B's here. So in terms of B, to get there from the center of enlargement, we would go 1, 2, 3, 4 to the right, and 1, 2, 3, 4, 5, 6 up. So instead of going 4 to the right and 6 up, we're going to half that. So it's going to be 2 to the right and 3 up. So 2 to the right, 1, 2, and 3 up. 1, 2, 3. So that's going to be where B dash would be. And then finally C. So to get to C from the center of enlargement, we go 1, 2, 3, 4 to the right and 2 up. So instead of going 4 to the right and 2 up, we're going to go 2 to the right and 1 up. So 2 to the right and 1 up would be here. So that's where C dash would be. So then if we just join up those points, so we just join them up, that one, and that one, that's where the triangle would be. Now I've labeled it A dash, B dash, C dash. You don't need to label them like that unless the question asks us to. No, you could just find out where they move to, and that would be there. And that's it. So we've enlarged this triangle ABC by scale factor of 1/2. So that means that all the sides are now half the size. So the top of it was 2, it's now 1. The height of it was 4, it's now 2, and so on. And it's half as far away from the center of enlargement. So this is where it would be. And that's it. Okay, let's look at our next question. Question number 19 says the diagram shows shape A, so this right angle triangle is shape A, and then we're told to draw an enlargement of A using a scale factor of 1/3. This is going to become 1/3 of the size with center of enlargement 1, 1. So the center of enlargement is 1, 1, which would be there. So that's where the center of enlargement would be. Now, in terms of the scale factor of enlargement, that's 1/3. So that means that all the sides are going to become 1/3 of the original size, but all the points are going to become 1/3 of the distance from the center of enlargement. So we'll divide all the distances from the center of enlargement by 3. So let's start off with this point here. To get to this point here, we go 1, 2, 3 to the right, and 1, 2, 3 up. So instead of going 3 to the right and 3 up, we're going to divide that by 3. Then we'll find 1/3 of it, which is 1. So that'll be 1 to the right and 1 up. So that'll be there. This point here, to get to this point here from the center of enlargement, we would go 1, 2, 3, 4, 5, 6 across, and 1, 2, 3 up. So instead of going 6 across and 3 up, we're going to divide that by 3 to find 1/3 of it. So that'll be 2 to the right and 1 up. So 2 to the right and 1 up would be there. And finally, this point up here. This point up here, we'd go 1, 2, 3, 4, 5, 6 across, and 1, 2, 3, 4, 5, 6, 7, 8, 9 up. So instead of going 6 across and 9 up, we're going to divide that by 3, and that'll be 2 across and 3 up. So we'll go back to the center of enlargement, we'll go 2 across, 1, 2, and then 3 up, 1, 2, 3. So it'll be there. And that's it, and let's just join those up, and that's it. So we've enlarged A by a scale factor of 1/3 using this point 1, 1 as the center of enlargement. So this would be the size of the triangle, and if you look at it, the base of this one was 3, and the base of this one is 1, and that's 1/3 of 3, which is 1. And the height of this one was 6, and the height of this one is 2. So that's 1/3 of 6, which is 2. And so the lengths would become 1/3 of the original size, and it's also 1/3 of the distance from the center of enlargement. So it'd be here, and that's it. So that's that question done. Okay, let's look at our next question. Okay, so question number 20. So question number 20, we've got this shape, this triangle on this grid, and we're told to enlarge this triangle by scale factor 1/2 using center 4, 6. So let's find out where 4, 6 would be. So 4, 6 would be up here somewhere. Let's get our pen. And 4, 6, 4 across 6 up would be up there. So that's the center of enlargement. And then we need to enlarge this triangle by scale factor of 1/2. Let's just check that. Scale factor of 1/2. So it means that all of these points will be half the distance from the center of enlargement. So to get from the center of enlargement to the top of the triangle, we would go 1, 2, 3, 4, 5, 6, 7, 8. So 8 to the left, and 1, 2, 3, 4, 5, 6, 7, 8 down. So instead of going 8 to the left and 8 down, we're going to go 4 to the left and 4 down. So 4 to the left, 1, 2, 3, 4, and 4 down. 1, 2, 3, 4. So that would be there. So that would be that point done. Now in terms of this point down here, to get to this point from the center of enlargement, we go 1, 2, 3, 4, 5, 6 across. We go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 down. So instead of going 6 to the left and 11 down, we're going to half that. So instead of 6 to the left, it's going to be 3 to the left. So 1, 2, 3. And instead of 11 down, we're going to half that. So it's going to be 5.5 down. So 1, 2, 3, 4, 5.5. So it'd be there because it's 5.5 down, because half of 11 is 5.5. And then finally, this bottom left-hand point here. So to get to this point from the center of enlargement, we would go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 across, and we would go, or 10 to the left, and then we'd go 11 down. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 down. So instead of going 10 to the left and 11 down, we're going to half that, so it's going to be 5 to the left and 5.5 down. So 5 to the left, 1, 2, 3, 4, 5. And then let's go down 5.5, so that'll be 1, 2, 3, 4, 5, and then a half, so we'll be there. So there are 3 points, and then let's join them up. So we just join up that point to that point, that point to that point, and then that point to that point. And that's it. So we've enlarged triangle A using scale factor of a half with center 4, 6. So using 4, 6 as the center of enlargement. And that's it. So we've done that question. Okay, let's look at our next question. Okay, so question number 21. So question number 21, we've got A and B, and then on this grid, and they're different sizes, so you can tell there's been an enlargement. And then we're told describe fully the single transformation that maps A onto B. So we're going to map A onto B. Now the first thing I notice is that whenever A has been enlarged, it's got smaller. So that means it's going to be a fractional scale factor of enlargement, well, less than 1, such as a half or a third or 2/3 or 3/4 or something like that. And so obviously A has been enlarged. Now it's got smaller, but that's okay. So it's still an enlargement. So let's write that down, an enlargement by scale factor, and then let's figure out what the scale factor would be. So in terms of the height of A, it's 2 up, 1, 2, and the height of B is 1 up, so that's been halved. And let's just check that with the base. The base was 2, now it's 1, it's been halved as well. So the scale factor is a half. A has been enlarged by a scale factor of a half. So the scale factor of enlargement is a half, and then we just need to say where the center is. So I've said that it's been enlarged by a scale factor of a half. We're using center of enlargement, so let's find where the center of enlargement would be. So to find the center of enlargement, we're going to choose the corresponding points. We're going to choose this one, and then draw a line straight through them, so it looks something like that. Okay, now this point and this point, draw a line straight through those, and it would look something like that. They're crossing here at the point 1, 5. Let's choose this point and this point and check it. And again, they pass through the point 1, 5. So the center of enlargement is the point 1, 5. So 1, 5, 1 across, 5 up. So that's the center of enlargement. So it says describe fully the single transformation that maps shape A onto shape B. It's an enlargement using scale factor of a half with center of enlargement 1, 5. And that's it. Okay, let's look at our next question, question number 22. Okay, so question number 22. Question number 22 is our last question, and we've got this grid, and we've got, it looks like 2 triangles here. We've got triangle ABD, so a little small triangle, and then a larger triangle ACE. So we've got these 2 triangles, ABD and ACE. And then the question says, describe fully the single transformation that maps triangle ACE, that's the larger one, to the smaller one, ABD. Okay, so because they're different sizes, if we look at them, so we want to see how do we get from the bigger one to the smaller one. Well, they've changed sizes, so it's an enlargement, and because it's getting smaller, we know it's going to be a fractional scale factor, but let's just write that down to begin with. An enlargement with scale factor, and let's find what the scale factor of enlargement would be. So if we consider ACE the big one, ACE, the base of it was 3 across. And then if we look at ABD, the base of it's only 1 across. So that's a third of it. That's if we divide it by 3, we get the length of that. So it's a third. The scale factor of enlargement there would be a third. Let's check on the heights. The height of triangle ACE, that's 1, 2, 3, 4, 5, 6, 7, 8, 9. If we do a third of that, that's 3. And the height of that one is 3. So the scale factor of enlargement is a third because it's a third of the size. So a scale factor third with center of enlargement, center of enlargement. And now we just need to say where the center of enlargement would be. Now this one's actually quite nice actually, because if we look at it, the point A stays where it is. So that means that A is going to be the center of enlargement. So A here is the center of enlargement. There's no point drawing the line from C through D and carrying on, and from C through B and carrying on, because they're all going to cross at A. And we can tell that because whenever it's been enlarged, A has stayed where it is. So obviously it hasn't moved. So that means that whenever it's been enlarged, it stayed where it is. So the distance hasn't changed. So that means that A is going to be the center of enlargement. And let's just check that. To get from the center of enlargement to C, we would go 1, 2, 3 to the left. But in terms of the scale factor of a third, if we divide that by 3, that's going to be 1 to the left. So that's where B's moved to, and so on. So the scale factor of enlargement is A, which is the point. Let's write down what the point is, 7, 1. So let's write that down. And that's it. So we've been asked to describe fully the single transformation that takes triangle ACE to ABD. So that's an enlargement with scale factor of a third using centre of enlargement 7, 1. And that's it. And that's it. So in this video, we've gone through the video solutions to the practice questions on enlargements. I really hope you found this video useful. If you have found it useful, please like and please subscribe to the YouTube channel. Thank you. Cheers. Bye.